Hello scholars, welcome back to iOS, Pieces of Scholars YouTube channel. Today we'll be examining and looking at probability distribution. So under probability distribution, we'll be looking at expected value of x and variance of x and sigma. Now the expected value of x here means the mean of the probability distribution, and this one stands for the variance of the probability distribution, and this one stands for the standard deviation of probability distribution. Here we go. If you have a question like this, probably it can be an assignment, it can be an exam question, it can be a test question. Your question will come in this form, and you have the table. You have been given the value of x. The sales is the value for the x, and the probability of each day per sales or each sales per day is the probability value we're having here. Now, for you to solve this question, the first thing we are looking at our expected value of x, which is mean of x. The expected value of x here will be defined as the summation of x multiplied by the probability of x. So this is the mean value, the x multiplied by the probability of x. So by solving this to look for the expected value of this, then my expected value of this is going to be 0, this 0, which is my value of x, which is this, multiplied by, what's the probability of that x? It is 0.03. Let me use this, 0.03. Then the essence of the summation here, that is going to make me make use of what? Plus, which is addition, because we have summation in the formula. So we have already applied the probability function of the value of x multiplied by probability of x, which is the one we have here. Then the other one we are going to have, the next value of x we have is what? 1, multiplied by the probability of 1, which is 0.2. You close it, plus, what's the next thing we have? We have 2 multiplied by 0.23. We have this, 3 multiplied by 0.25. We have this, 4 multiplied by 0.12, plus 5 multiplied by 0.10. Then you continue here, plus 6, which is the last one, multiplied by 0.07. Then we need to find the value of all these addition. So at this place, after having the multiplication of the expected, the probability of x multiplied by value of x, we have this. So 0 times 0.03 is giving us 0. 1 times this, we arrive at this. This, give you the value for this. And when you multiply this by this, you are going to get 0.7 as it continues like that. Then the summation of everything results to this. So the expected value of x is what gives us this. Then to solve the next question, which is the variance, then I'll use this place for variance. Then I'll need to clean the board for further explanation of variance. The formula for variance, which is known as v of x, is also known as sigma square of x. When you see the sign sigma square, is the same thing as you are looking for the what? The variance, where the formula is the expected value of x squared minus the expected value of x all squared. So this is the application of the probability distribution for us to get our variance. The expected value of x is 2.81, like I said. Then for you to get your variance, we have this application. And then don't forget that I let you know that your variance is the same thing as you're looking for the sigma square. Now we need to examine this. By solving this, the expected value of x squared is going to give us x squared. In fact, sorry, it's going to be summation x squared multiplied by probability of x. Now in this case, we are dealing with x squared multiplied by probability of x. What did I mean? To analyze this now, the expected value of x squared will equal to what's the value of my x? The value of my x represents this first row, and my probability represents the second row. Now the value of my x here, therefore that means I'm going to have 0 squared multiplied by what's probability? 0.03. Then you close the bracket, plus, then what's the next thing? You have 1 squared multiplied by what's probability? 0.2. Then plus the addition sign I'm introducing here, it works for the summation that we have in the formula. Then plus the next one, we have 2 squared multiplied by 0.23. You have this, what's the next thing? 3 squared multiplied by 0.25. Then you have the next thing, 4 squared multiplied by 0.12. Plus you have 5 squared multiplied by 0.10. Then plus you have 6 squared multiplied by 0.70. Sorry, 0.07. You have this. Then the application of this to further, in order to solve this further, this 0 square is going to give you 0. It's going to give you 0 multiplied by 0.03. You had it. This one square is still going to give you 1, 0.2. Plus the 2 square here is going to give you 4. You have times 0.23. Then plus the 3 square here is going to give you 9. 9 times 0.25. Plus it, 4 here is going to give you 16 times 0.12. And the last, sorry, not the last, 5 square is going to give us 25. This times 0.10. Then I'll continue here. Plus we have 6 square here. 6 square is going to give you what? 36 times what? 0.07. Yeah. Then therefore I can evaluate my expected value of x squared to be the square of the value for x multiplied by the probability of x. So the value of all this square or whatever the expected value of x squared is giving us this. Then by the application of the summation, that's the essence of the addition that is here. I've been saying that times without number. Then the actual final answer for the expected value of x squared is 10.31. So expected value of x squared is 10. So what I've done here, I've only arrived at the answer for this. Then we need to apply this too. So to look for the variance now, the variance of x is going to give me 10.31, which is this. Subtract from the expected value of x all square. We already know our expected value of x. All we have to do is to apply this square. Then the expected value of x is what? 2 points. We have 2.81. The expected value of x is 2.81. Then don't forget the application of the square. Then my final answer, or the next step for the variance before getting the final answer, is to find out the square of this. Then I have 10.31 minus, so the value for 2.81 squared, that is the expected value of x all square. When you square this, 2.81 raised to 2 is going to give you this. You can confirm that with your calculator. Please work along with me so that we can confirm all these addition, subtraction, and the square, whatever it is here. Now, when you subtract the expected value of x squared and you subtract the expected value of x all square from the expected value of x squared, which is 10.31 minus 7.70, you arrive at your variance to be this. And this is the final step of getting your variance. Then the simplest one of it is your sigma, which is the standard deviation. Don't forget that we are looking for the mean. This is the mean. In probability, we don't call it mean. You call it expected. It is expected value. So, and this is the variance. And the probability that we use, the probability notation that we use for variance under probability distribution, you call it sigma square. Let me write it again for you. This is it. Yeah, it's here. Sigma square for variance. But for standard deviation or standard error, we call it sigma. And how do we arrive at this? We arrive at this as sigma because sigma or standard deviation is the square root of your variance. Square root of the variance. And that means whatever I get from my variance, I'm going to square root it. And what's the value for my variance? My variance is 2.61. Then to get my standard deviation, I'll need to square root this. Then what will be the value? The square root of your variance now equals to 1.62. I hope you understand the step-by-step way for you to get your expected value of x, the variance of x, and the standard deviation of x under probability distribution. Please don't forget to subscribe on our YouTube channel. This will encourage us to do more and perform better.